Okay, so Jessica and Morgan work for different companies. Jessica has a salary based on has a base salary of 36,000. So I'm going to underline Jessica's stuff in blue. So Jessica has a base salary of 36,000 and will receive an increase in salary in the rate of 3.1% per year. So I circled that in blue. In red, Morgan has a salary base of 38,000 and will receive an increase in her salary of 2.5 per year. Okay. So Jessica and Morgan are calculating the numbers of years it will take for them to earn more than 45,000 at their prospective companies. Okay, so let's look for Jessica's first. So Jessica, her initial condition is 36,000. So we're going to look for one that has 36,000, and then it's going to be 1 plus 0.031, right? Because that's what's going in the parentheses, and raised to the t. So I think this is the formula for Jessica. And I'm not going to do it now, but you could graph the left-hand side of this and the right-hand side, and you'll see that it's in the 8th years when it surpasses that. So hers surpasses in the 8th year, okay? But now we want to look at Morgan's. So Morgan has an initial value of 38,000. So we got to find one that has 38,000. But her percentage is 0.25. In other words, at some point we're going to say 1 plus 0.025, like that, 0.025, which will be this one, I think. No, it can't be because it says 36. Right? It's got to say 38. So it's this one. So that's the inequality to calculate Morgan's. But then if we want to figure out when it's greater than 45,000, that doesn't occur until the 7th year. Okay, and again, what I would do is I would graph this side and I would graph this. I would say y equals 38,000. We'll say y1. 1.025 raised to the x. And then I would graph for my second equation 45,000. And then I would look to see when those two are equal. Okay? And I would do the same thing with blue, with Jessica's stuff. And that'll give me the 7th and 8th year corresponding. Okay?